Hi friends, good morning to everyone. In the last session, we have focused on control statements. We have explored conditional control statements, unconditional control statements. Hope all of you have gone through that. Have any doubts in the last session? Any doubts? Okay, let us solve problems in the session. First one, please take it. Find the given integer is odd or even using switch statement. To check if the given integer is odd or even, we can simply use the if statement, if conditional test. If n mod 2 is equal to 0, we have concluded that the given integer is even. If n mod 2 is not equal to 0, then the given integer is odd. That is one way to check if the given integer is odd or even using if else statement. The same problem could also be solved using the switch case statement, because in the switch case, in the conditional part, we can have the evaluation that results in a numerical quantity. So based on the remainder value, right, either 0 or 1, the value can be passed to the case block statement, right? Then we can print or process as the given integer is odd or even. So this is another way using a switch statement to solve the problem. Let us solve the problem by including a header file hash include stdio.h. Then define a main function int main within the opening and closing curly braces. We are writing the processing statements. Let us declare one variable int n. We can get the value of n through the keyboard. So I am writing printf hash n, enter the integer, write a scanf statement, scanf percentage d ampersand n. So n is obtained into the variable, right? The input is obtained into the variable n as the integer 1. Now let us pass the value of n to the switch statement in such a way that the value of n should be determined as odd or even. This is the problem. What is the syntax of a switch statement? What is the syntax of a switch statement? How switch works?
Case 1 expression break and it is followed by until ends.
Okay, a switch rate after switch we need to specify the expression. The expression should be evaluated. The value of the expression should be passed as a parameter to value of the expression, right? Switch expression that is evaluated, and this can be passed right as a function as a parameter to the case labels. Is value sent to the corresponding case block labels in an order. So in that case, we need to properly determine if n is odd or even. So to determine that, shall we write here switch expression switch after switch, right? The keyboard, since this is a keyboard, it is highlighted. Shall we write the expression as n mod 2 to switch n mod 2? So switch, this is the expression n mod 2. N mod 2 is evaluated so that the result is either 0 or 1. So if the result is 0, this indicates that the given integer n is even. So how can we write a case statement? Case, then 0, then here we can write printf slash n, printf slash n, percentage d is even, comma n. We are printing the message as, suppose 10 is even, right? 10 is the value of n.
Sir,
This
printf, sir.
printf, yeah, printf. 10 is even. Can receive the value of 10. After that, logically we need to give a break statement. Then only control comes out of the switch block. Otherwise, it executes the successive case statements repeatedly, so that it will get incorrect result. So write case 1. Here I write printf slash n, percentage d is odd, n, the value of n is printed here. After that, right, there is no need to put a right break for case 1 unnecessarily, right? We need not put. Then after this, return 0 terminates, right, the program execution, and the control is transferred to the calling place, right, operating system. Let us save the file save cp29. Program has been compiled successfully. Control F9. Enter the integer 100. 100 is even. Control F9. Enter the integer 121. 121 is add. So understand, a switch is a multi-branch statement. The expression is evaluated. The value, right, should be matched with the corresponding case labels. If not, right, we can specify a default block. So the value is tested against the case labels in an order. First case value, second case value, third case value, etc. When there is a match, right, the specific case statements are executed. When there is no match, in case if we have given a default block, finally default block will get executed. In case no default block, right, then control, it comes out of the switch block, then finally the statement to be executed is here, for example, a return to 0. So the same logic, right, could also be replaced by using if else statement. If n mod 2, then we can write through the statements, right? N mod 2 is equal to 0, right? 0 means, right, even, right? Else we can write the given integer is add. Have any doubts in this example using switch case statement? Have any doubts in this example? Okay, we move on to the next one. Let us evaluate the series. In this example, I like to evaluate the sine series. Evaluate the sine series up to the first j terms or n terms. What is sin x? Sin x is equal to, what is the formula for sine series? X minus x power, right? I use this notation. For example, x power 3 by 3 factorial plus x power 5 divided by 5 factorial minus etc. This is the sine series. So sin x is equal to x minus x power 3 by 3 factorial plus x power 5 by 5 factorial. What is x? X is in degrees or radians?
Radians.
Very good. Radians. Sin x is equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial minus etc. First of all, the input value x is in radians. If we are giving the input value in degrees, this should be converted into radians first, and then the updated x should be passed as, or updated x should be used in the right hand side of the series, sin x equation. So first, let us convert the degree to radian relationship. What is the relationship between degrees to radians? Pi radians is equal to 180 degree. So pi by 180 radians, this is equal to 1 degree. Assuming that we are giving the input in terms of x degrees, this x degree should be converted into the equivalent radians. Since 1 degree is equal to pi by 180 radians, this implies multiplying the equation by x degree on both sides, x degree is equal to pi by 180 into x radians. So pi, right, we can use pi is equal to 3.14159. So after getting the input value x in terms of degrees, x degree, right, should be processed to the equivalent radians as x is equal to x into pi by 180. That we can write as a single assignment statement for the conversion from degrees to radians. Second thing, how to evaluate this right hand side, x minus x cube by 3 factorial plus x power 5 by 5 factorial minus etc. That is the question. We have the terms. First term is x, second term is x power 3 by 3 factorial, third term is x power 5 by 5 factorial, then fourth term x power 7 by 7 factorial, fifth term x power 9 by 9 factorial. These are the individual terms. Terms 1, term 2, term 3, term 4, term 5, etc. In this, we have the right hand side. The terms are right summed. The alternate plus minus signs are there. First term is plus, notice it. Second term minus, third plus, fourth minus, etc. That is important. Here the sign is plus. Here minus, plus, minus, plus, minus, etc. In this example, we use one variable j, for example, or to indicate the number of terms to be processed. So j, which indicates the number of terms to be evaluated. Suppose j is equal to 2 means we need to evaluate only, for example, s is equal to x minus x cube by 3 factorial. Suppose j is equal to 3, we need to evaluate s is equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial. That means the first three terms are to be considered. First term, second term, third term. Here, this is the first term, this is the second term. Right? Now let's see how to evaluate the individual terms. It seems first term is right x, second term numerator is x power 3, third term numerator is x power 5. Since the numerator is in the form of x, x power 3, x power 5, x power 7, x power 9, etc. It seems when the term x is multiplied by x square, we have x into x square x power 3. Then x power 3 is multiplied by x square, we have x power 5. X power 5 is multiplied by x square, we have x power 7. So if we find each term as a numerator by denominator, for example, numerator, right, once you initialize the first term x, the subsequent terms are obtained by multiplying the current numerator with x square. Currently numerator is x, for example, x into x square, right? We have the updated numerator x power 3. Currently numerator is x power 3. The next numerator is obtained as x power 3 into x square x power 5. So numerator there is no problem. Denominator we need to find the values. Actually this x is nothing but x by 1 factorial. Here x by 1 factorial. Here also x by 1 factorial. We need to find the factorial of add integers. For example, 1 factorial, 3 factorial, 5 factorial, 7 factorial, 9 factorial, etc. Here, first term, right, 1 factorial. Second term, x power 3, this should be divided by 3 factorial. X power 5 is divided by 5 factorial. X power 7 is divided by 7 factorial. So this can be brought in different ways. We can design a logic in a different ways. I tell you, right, one possible logic. Here 3 factorial with respect to the term. This is the term, right? J is equal to 1. When j becomes 2, the 3 factorial is nothing but I write 2j into 2j plus 1. Is this what happens to 2j? 2j is 4. This is 4 plus 1, 5. So 5 up to 5 factorial this works. Or this works for 5 factorial. So I modify the logic here starting from j as 1 here. Then j is equal to 1. If I write 2j into 2j plus 1, I have the values 2 into 1 plus 1, 3, 2 into 3. Initially, right, if you set denominator is equal to 1, writing denominator is denominator into 2j into 2j plus 1. We have 1 into 2 into 3. Yes, 3 factorial is obtained. Then to process 5 factorial, start j as 2. Here what happens? J as 2 means current denominator is 3 factorial. When 3 factorial is multiplied by 2j into 2j plus 1, 2j, 2 into 2, 4, then 2j plus 1, 4 plus 1, 5. We have 3 factorial into 4 into 5. This is the value of 5 factorial. Likewise here, to process the 7 factorial, for j is equal to 3, Current denominator is 5 factorial. When this is multiplied by 2j into 2j plus 1, 2j is 6, 2j plus 1 is 7, 5 factorial into 6 into 7 is 7 factorial. So the denominators 3 factorial, 5 factorial, 7 factorial, etc. are achieved in this logic. We need to evaluate, right, numerator by denominator, and the alternate signs are required because first term is plus, second term is minus, third term is plus minus. In the last class I said, right, at the end of the session, to bring the alternate plus and minus, initially it can use one variable, for example sign. Sign is initially set to 1. That means sign is positive. When we evaluate a numerator by denominator, every stage this is multiplied by sign. Currently sign is 1. So after the first term is evaluated, next to evaluate the second term, we need to revert the value of sign. We can write sign is equal to minus sign. That means current sign is 1. 1 is negated using unary minus operator. So that we have this minus. Minus into 1 becomes minus 1. Next stage, numerator by denominator into sign. What happens? That sign becomes a negative quantity. Then next stage, sign is equal to minus sign. Minus 1 into, right, again, right, unary minus, that becomes a plus 1. So plus minus plus minus plus minus, that means the alternate terms signs are extracted right of time. Only thing we need to control through some fixed number of terms are first j terms, right? First j, as we discussed, right? J is equal to 2 means first 2 terms are to be evaluated. J is equal to 3 means first 3 terms are to be evaluated. So we need to carefully control through a for loop, while loop, or a do while loop, so that the first j terms need to be evaluated and the result should be updated in the variable to say yes. Initialize s is equal to 0. This is the logic to find out the evaluation of a sine series. Now let us convert this logic into the program and then verify if the program is working correct or the logic is working correct. So let us write the code now. Please listen. First include the header file hash include stdio.h, writing a main function int main. Within this opening and closing curly braces, write the complete processing statements. First, let's decide, right, what is our input. Input is x. X is right in terms of degrees. Suppose we have the input x in terms of a floating point quantity, a float x. Suppose x is 30 degree. Since we are performing the arithmetic, right, numerator by denominator, entire calculations are right processed in the floating point mode. That's what we are declared the variable x as a floating point quantity. The purpose of x is to give the input x in degrees. First, let me get the input value of x. Printf /n, enter the value of x in bracket I mentioned as in degrees. The value of x is given in terms of degrees. So writing a scanf statement, scanf percentage f ampersand x, right? It's convert x degrees into radians before evaluating right hand side. So what is our calculations? X degree is equal to pi by 180 into x radians. Shall we write how to implement this equation? X is updated as x into pi by 180. Sorry, we write x is equal to x into pi. You can use the symbolic constant if you want, right? There you can use before the main function has defined pi 3.14159, or you can directly use here x into pi by 180. Pi, right? We have used 3.14159 by 180.0 as a floating point quantity. So x degrees measurement is converted into the equivalent radians. Further, the updated value of x should be given as input to the right hand side evaluation, x minus x bar 3 by 3 factorial plus x bar 5 by 5 factorial. We are going to input one more value, for example j. What is this j? J defines the number of terms. For example, write another statement, printf slash n, enter the number of terms to be evaluated. Scanf percentage number of terms, right? Let us use the integer variable percentage d, comma. We can use one variable, for example, a term or terms. So terms is a variable which defines the number of terms. I declare here into terms which defines the number of terms to be evaluated. Next, have a look into our logic. We need to evaluate, right, the numerator by denominator. Every stage, if we evaluate the expressions, numerator and denominator, we can write simply sum is equal to sum plus numerator by denominator, where numerator by denominator is appropriately multiplied by the sign. And we need to control through exactly the terms, number of terms. So I use the variables right here, numerator and denominator, as a floating point variables. Numerator, comma, denominator, sorry, dr, to indicate the numerator and the denominator. For example, if we start for j is equal to 1, j less than or equal to terms, is why we modify the logic rate by checking its correctness. J plus plus. Then j is equal to 1. We need to evaluate this term x. That means sum is equal to x X is also defined as numerator by denominator, where numerator is x, denominator is 1. So I initialize denominator as 1 here. So denominator is equal to say 1.0. If we write here for the first term numerator by denominator, then this should be multiplied by x square to bring the next term. So to avoid that, right, to have a correct logic, after getting the value of x, I initialize the variable numerator. So I write here numerator is set to x. So when j is equal to 1, what happens? We expect sum is equal to sum plus. So please wait. I write one variable s here, float s. This has been s. This has been set to 0. S is equal to 0. If we write s is equal to s is equal to s plus numerator by denominator, and this will be multiplied by one sign. So s plus numerator by denominator star sign, and I initialize sign as a positive quantity. So sign has been set to 1 initially. Then if we bring sign is equal to minus sign, this is minus sign. We need to ensure, right, the next term is properly obtained. So in this case, when j is equal to 1, what happens? S is equal to s plus, current s is 0, of course. S plus numerator is x, no problem. X by denominator. What is the denominator that we need to set? Initial value of denominator is 1.0. So numerator is x by denominator 1.0, sign is 1, s is 0. It seems the value of s is x. Okay. Next, we need to update the value of numerator and denominator. So here, if you write first numerator is equal to numerator star x square, x into x, and the denominator is equal to next stage, right? What will be the denominator when j is equal to 1? When j is equal to 1, we are bringing the value of 3 factorial as current denominator into 2j into 2j plus 1, because when j is 1, 2j is 2, 2j plus 1 is 3. So it seems 1 into 2 into 3, 3 factorial. This is stored in the current value dr, so that this 3 factorial is processed in the next stage calculation. So here I write, we try write initially denominator. What is the current denominator? Current denominator has already been set 1.0. Denominator into 2j into 2j plus 1. So I write 2.0 star j star 2.0 2.0 star j plus 1.0, then sign is equal to minus sign. Now let us check its correctness again. When j is equal to 1, s is equal to s plus numerator by denominator into sign, no problem. S is equal to x, s is equal to x, because numerator is x, denominator is 1, sign is 1, s is equal to x is obtained. So when j is equal to 1, only one term need to be evaluated, that is a value of x. Numerator and denominator, right, are computing the values for the next stage calculation, right? So if you put j is equal to 1, only the value of s is x. In case if we put terms, right, sorry, terms is equal to 1, right, only, right, what happens, 1 less than or equal to 1, condition is true. So only the variable x is evaluated. Suppose terms is equal to 2, when j is equal to 1, x is evaluated, then numerator is updated as current x into x square, that is x power 3. Denominator is updated as current denominator 1 into 2 into j, right? J is 1, so 1 into 2 into j is 1, then 2 into j plus 1.0, or 2 plus 1, 3. So it seems 1 into 2 into 3, 3 factorial is computed in the variable denominator. Sign is negated, sign is equal to minus sign. Since currently terms is equal to 2, j is incremented by 1, 2 less than or equal to terms 2, condition is true. Now s is equal to s plus current s is x, numerator is x power 3, because when j is equal to 1 itself, the numerator is evaluated, and numerator is x power 3, denominator is, right, 3 factorial, that we have evaluated when j is equal to 1 itself. Sign becomes minus 1, so it seems x power 3 by 3 factorial, this is evaluated in numerator by denominator, and when this is multiplied with sign, current sign is minus, so we brought this term minus x power 3 by 3 factorial. So s is equal to s plus numerator by denominator into sign, updates x minus x power 3 by 3 factorial, which is stored in a variable s. Then this numerator, denominator and the sign, this is for the update of next value of j. Since the terms is 2, 2 less than or equal to 2, that's all. Then j plus plus 3 less than or equal to 2, for example, condition false, control comes out of R. So first terms are evaluated. Suppose terms is equal to 2, 2 terms are evaluated. When terms is equal to 3, first 3 terms are evaluated, and the result is updated in the variable s. Finally, we need to print the value of s. Print of slash n, s is equal to percentage f, comma, the variable s needs to be printed. The value of s is printed. Understand the logic? Understand the logic? First, let us test the code, right, and verify its correctness again. File name, file cp30 f9, one error, index variable, right, j need to be defined. Okay, for int declare int j comma terms comma sign is equal to 1, f9 Yes. Control F9. Enter the value of x in degrees. Suppose x is 0. Enter the number of terms to be evaluated. One term. Sum is 0. First term, right? X minus x cube. X itself 0. Control F9. Enter the value of x. For example, sine 30 degree. Enter the number of terms to be evaluated. Say 2 terms. Sine 30, right? 1 by 2. So we have a value 0.49. Accuracy gets increased when we increase the number of terms. So mathematically, when we increase the number of terms, accuracy gets increased. So you try to increase the terms, but when you increase the terms, here the values should be evaluated, right, with respect to a floating point mode. Otherwise, you try to introduce the long integer variable to have more accuracy. Now let us trace this logic to check the value of s is correctly obtained or not. Hope you have understand right up to these things, getting the input value of x, converting x degrees into radians, then numerator is obtained, right, or assigned to the variable yes, assigned to the variable x. Suppose consider the terms j, checking if j is less than or equal to terms, then we need to have a variable sign, then numerator, denominator, and s is equal to s is equal to s plus numerator by denominator multiplied by sign. Having these columns, first fill the initial values of the variables. Then let us evaluate the for loop. Initially, the value of x is given as the input. Denominator is 1, sum is 0. So update it properly. The denominator is 1, 1.0, sum is 0. Then after updating the value of x, numerator is updated to x. Numerator is updated to x. So after inputting the value of x, right, x is converted into the radians. Sine is 1.0. Initially no j. These are the initial values. Suppose here I write, let us evaluate for 3 terms for some x. When terms is equal to 3, please understand carefully. Now we are in this step. Control enters into the for loop. This logic needs to be traced to ensure the correctness of our evaluation. J starts at 1 for j is equal to 1. So I write here the initial value of j is 1. Entry condition into the while loop is j less than or equal to terms. J 1 less than or equal to terms. Suppose terms is 3. 1 less than or equal to 3. Condition is true. Then sum is equal to sum plus numerator by denominator into sine. So evaluate this value first. S is equal to. I write s is equal to, right? Left hand side is the variable s. So current S is 0 plus numerator by denominator. It seems the current numerator is x, denominator is 1, right? Then into sine is right 1. So 0 plus x by 1 into x, that is x. First term, right? This is updated in the variable yes. After this update, we are making three important things. One is updating the variable numerator. Numerator is updated to numerator into x into x. Have a look into this statement. Numerator is updated to numerator into x square. So I update the numerator when j is equal to 1 itself. So numerator into x square means this becomes x power 3. Then denominator is equal to denominator into 2j into 2j plus 1.0. So I evaluate here denominator, current denominator 1 into 2j. 2j, right? This is j is 1, this becomes 2. 2j plus 1, 2 into 1, 2 plus 1, 3. For example, I write as integer values 1 into 2 into 3. Current denominator multiplied with 2j into 2j plus 1. So 2 into 3, 6. I write this as 3 factorial. Then updating the variable sign. Sign is updated to minus sign. So here minus sign is unary minus operator is employed. 1.0 becomes minus 1.0. This is the trace when j is equal to 1. Next, what happens? J is incremented by 1, j plus plus. Upon the execution of j plus plus, I write here j plus plus. Now the value of j is 2. This is the new value of j. J less than or equal to terms, say 2 less than or equal to terms is 3. Condition is true. Then updating the variable s first. S is equal to s plus. Current s is x plus numerator. Numerator is this one, x power 3 divided by this denominator. Denominator is actually 3 factorial. This is multiplied with the variable sign here. Current sign is minus 1.0. It seems mathematically this is x minus x power 3 by 3 factorial. Since we are in j is equal to 2, first two terms are evaluated and the result gets updated in the variable yes. In j is equal to 2, in this iteration itself, the variables numerator, denominator, sign are updated for the next term evaluation. So we are updating the variables now itself. Numerator gets updated x power 3 into x square. This becomes x power 5. Denominator is updated as current denominator into 2j into 2j plus 1. Understand, current denominator is I write as 3 factorial into 2j. 2j means 2 into 2, 4. 2j plus 1, 2 into 2, 4 plus 1, 5. So it seems 3 factorial into 4 into 5. We brought the value of 5 factorial in the variable denominator. Then sign gets negated. Sign is equal to minus sign. Current sign is negated. Current sign is minus 1.0. So here this becomes plus 1.0. Next, j gets incremented by 1, j plus plus. What happens? J becomes 3. J becomes 3. So current j is 3. Checking the entry condition 3 less than or equal to 3. Condition is true. First update a value of s. S is equal to s plus. I write the current is as it is, x minus x power 3 by 3 factorial. Current is plus numerator by denominator. Current numerator is this one, x power 5, x power 5, current numerator. Denominator is this one, 5 factorial. This is multiplied by current sign, right? Have a look into here. Current sign is plus 1.0. So 1.0. This is logically x minus x power 3 by 3 factorial. Plus, right, we brought the positive sign here, x power 5 by 5 factorial. This evaluation is updated in the variable yes. Then numerator, denominator, sign gets updated for next stage evaluation. So it seems the numerator is x power 7, denominator is already 5 factorial. So 2j into 2j plus 1, 2j, j is 3, 2j is 6, 2j is 6, 2j plus 1, 6 plus 1, 7. So this is just 7 factorial to be used for next stage calculation, and the sign is negated, sign becomes minus 1.0, then j plus plus, what happens? J becomes 4. So the final value of j, here when j becomes 4, checking the entry condition, 4 less than or equal to 3, condition is false. So control comes out of the for loop. Clearly, the next executable statement is printing the value of s. What is the value of current s? Current s, right? This is the updated value of x. X minus x cube by 3 factorial plus x power 5 by 5 factorial. It seems since we have terms as 3, the first 3 terms in that sequence are 3 terms, right? X power 3 by 3 factorial, x power 5 by 5 factorial are evaluated, and we have the correct result. Similarly, when a terms is equal to 5, first 5 terms are evaluated, terms is equal to 10, first 10 terms are evaluated, terms is 1, right? The first term, right, alone, s is equal to x gets evaluated. So the input value of terms, right, that should be greater than or equal to 1. So we have reached or obtained the correct value of s. This is a way to ensure the correctness of our algorithm or correctness of our program logic. Have any doubts in this example? Have any doubts in this example? Understand the logic?
Yes, sir.
Don't mug up the lines of code, right? This will not remain right in your mind. So understand the logic, right? Based on the logic, we need to design the implementation. That is important. Since here the terms are right going, the multiplication of x square, x into x square, x power 3, x power 3 into x square, x power 5. So we have split the term into numerator by denominator. Numerator is obtained carefully. Denominator we bring right 3 factorial, 5 factorial, 7 factorial. So it seems when j is equal to 1, 2 into 2 plus 1 is 3. J is equal to 2. 2j into 2j plus 1, right? That is 5. So this is one possible logic. Even right, you can find right another logic, right? For example, the first term is x power 2n minus 1 by 2n minus 1 factorial. X power 2n minus 1, right? Put n is equal to 1. There 2 minus 1, 1. X power 1 by 2n minus 1 within parenthesis, then factorial. 2 minus 1, 1 factorial. Second term is x power 2n minus 1. Putting right a term as 2 or n is equal to 2. X power 2 into 2, 4 minus 1 x power 3 by 2n minus 1 factorial. So we have 3 factorial. Likewise, putting n is equal to 3, x power 2n minus 1 by 2n minus 1 factorial. We have a value x power 5 by 5 factorial. There you need to properly design a code to bring the denominator values as 1 factorial, 3 factorial, 5 factorial, etc. So here in this example, we are not using functions concept. Later we use the concept of function. So once we define a factorial function, we simply call a factorial function, right? To find 3, 5, 7, 9, etc. Alternate plus minus signs, right, can be easily brought. Initially, right, think of what sign is required. Since the sign is plus for x, so initialize sign as plus 1 and multiply the numerator by denominator with the sign. Next, since the next sign is minus, in the for loop, you need to update a value of sign. Sign is minus sign. That means current sign is negated, so that when you obtain the value of sign, next value of j, the current sign will get negated. Then sign is equal to minus sign, right? So unary minus operator simply negates the value of sign. Alternately, we are bringing the signs plus minus, etc. This is the logic. This is one way to solve the problem, right? Even you can use a while loop or do while loop, or even you can change the logic of for, right? The computations, numerator, denominator. Or you can ask, right, why should we unnecessarily evaluate numerator, denominator, sign for the next stage, right? The last value of j. So if you want to modify, right, so try to cut this and find a logic accordingly so that this computation can be brought right before s is equal to s plus numerator by denominator and initialize the value of s as x. If you initialize the value of s as x, right, then s is equal to s plus, right, this will be right brought at the end so that we can modify the value of j. Unnecessary computation for numerator denominator sign in the last stage evaluation can be eliminated. But anyhow, right, this logic exactly evaluates the terms, number of terms, so that the correctness of the program is approved or correctness of the algorithm is proved. Hope you understand this example. Likewise, you are asked to evaluate the cosine series where cos x is equal to what is cos x? You remember the formulas, it will not be given in the question paper. So 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial plus etc. Alternate series, right? Here the terms are 1 into x square numerator, x square into x square, we will get x power 4, x power 4 into x square, we will get x power 6. Numerator, no problem. Denominator, right, you need to have this one, x square by, right, 2 factorial, x square into x square, right here, x power 4, x power 4 divided by 4 factorial. Here x power 6 divided by 6 factorial. So find a logic accordingly, right, to evaluate 2 factorial, 4 factorial, 6 factorial based on the value of j. J is equal to 1, j is equal to 2, j is equal to 3, etc. So once you find the correct expression, as we used 2j into 2j plus 1 for sine series to try to check it for options, right? 2j into 2j minus 1, then or 2j into 2j plus 1, right? For different values of j. Then you can bring the signs alternately plus minus, and we have the common statement s is equal to s plus numerator by denominator into sign. Control through the first terms number of terms, so that we need to evaluate right the cosine series and ensure its correctness. Check if the terms number of terms first terms number of terms are actually evaluated in your logic. Is it possible for you to solve cosine series? Have any doubts in cosine series? Likewise, you can evaluate right the exponential series. The exponential series is given using e power x formula 1 plus x power 1 by 1 factorial plus x square by 2 factorial plus x power 3 by 3 factorial plus etc. Infinite series. Here also control through first j terms, so that we can evaluate numerator by denominator. Here continuous factorial is there. 1 factorial, 2 factorial, 3 factorial. So we can easily design a logic, right? Initially fact is 1, then fact is fact into current to j. J is 2 inside 2 factorial. When j is 3, current factor, right? 2 factorial is multiplied by the j, 3 current to j. You will get a value of 3 factorial. So that you can find the sum, updated value of sum. S is equal to s plus numerator by denominator. The thing is, in the exponential series, we have all the terms, right? Sign is positive 1. So we need not have the variable sign. So simply we can find s is equal to s plus numerator by a denominator. So that the first j terms are going to be evaluated. As we have seen here, right? The first terms, number of terms are going to be evaluated. Have any doubts? If you have any doubts, now you can ask. Any doubts?
No, sir.
Okay, please go through the session. I post the material, right, and a video after some time. Please go through the session and please solve, right, these two exercises. Cosine series and exponential series for the first j terms. And if you find, right, any problems, right, ask me, right, I will solve it. Okay, thank you very much.
Thank you, sir.
Thank you, sir.